Hello geometry students, Mr. Gazzato here, and today's learning target is to talk about the properties of parallelograms. So the first thing I'm going to tell you is the definition of a parallelogram. The definition of a parallelogram is both pairs of opposite sides are parallel. So both pairs of opposite sides are parallel. And I'm going to mark them with these red marks that we did earlier in the year. So if we take a look at the parallelogram on your screen, you can see the parallel line marks. If you look at the opposite sides, what do you notice? I'm going to drag this point. Is your observation still true? I'm going to drag it again and again. And hopefully you realize the opposite sides are also congruent. So we have 6.6 for DC, 6.6 for AB, 7.58 for AD, 7.5 for BC. So the second property of parallel lines is opposite sides are congruent, both pairs. So both pairs of opposite sides are congruent. So I'm going to mark that with one tick mark, two tick marks, two tick marks. Let's look at another property. If I look at this again, notice the red angles are identical, D and B, and the green angles are identical, A and C. If I were to drag and move the parallelogram around, notice the angles are still the same. We call A and C opposite angles. We call D and B opposite angles. So the third property is opposite angles are congruent. So I'm going to put this green mark on A and C, and I'll use two arcs for D and B. And just for clarity, I am going to add the word both pairs of opposite angles are congruent. All right, fourth property of a parallelogram. I'm going to go back to this screen. If you remember, if the lines are parallel, angle D and angle A are called same side interior angles. And if you look at angle D and angle A and you were to add them up, you will get 180 degrees. If I were to make the parallelogram different, again, D and A are same side interior angles, and if you were to add those two up on your calculator, you will get 180. Also, angle D and C are same side interior angles, and if you look at this, D and C add up to 180. So the fourth property of parallelograms is, and we call these consecutive angles. So consecutive angles are supplementary. And I'm going to write that down here. For instance, angle A, the measure of angle A plus the measure of angle D is 180 degrees. Remember, supplementary means 180. Likewise, angle D plus angle C is 180. Angle C and angle B add up to 180. And angle A and angle B all add up to 180. And then there's one more property of parallelograms. So if I were to draw in the diagonals, you will notice here that we have 6.05, 6.05, 6.58, 6.58. If I were to drag the parallelogram and make it a little different, we have 5.5, 6.51, 6.51. Notice that E is the midpoint of both diagonals. So no matter what happens, E is always going to be the midpoint. So the way we say that in geometry here is we say the diagonals bisect each other. And I'm going to redraw a parallelogram here and just mark that visually in the diagram. So we have a parallelogram. I'm going to mark it parallel. I'm going to draw in my diagonals. And each piece is congruent. So I'm going to put one tick mark here in green for those two pieces being equal. And then in black, these two pieces are equal. So these are the 5 properties of a parallelogram. And the goal today is to use these properties to find various information about parallelograms. So let's take a couple minutes to look at these examples. In problem number 1, we have a parallelogram, and we want to find JH. Well, JH is highlighted in yellow. It is opposite to FG, so that is going to be equal to 5. The second thing is we want to find the segment FK, which I'm highlighting here in green. That is a portion of the diagonal. Since the blue piece is 3, those two pieces are equal, so this piece is equal to 3. In problem 2, we have another parallelogram, and we are told that angle P is 70 degrees. So we learn that the opposite angles are equal, so that means angle R is also 70 degrees. And the second thing we learned is consecutive angles are supplementary. So angle Q and angle P add up to 180. So to find angle Q, we could do 180 degrees minus 70, and we will get 110. Take a look at problem number 3. If you'd like to pause the screen and try it on your own, please do so. In problem number 3, angle S and angle R are consecutive angles, so they are supplementary. The equation we would write is 3x plus 120 is equal to 180. We'll subtract 120 from both sides. We will get 3x is equal to 60. Divide by 3. X is equal to 20. Let's look at the problems on the next page. So looking at example 4, the goal here is to find the measures of angle Q and angle P. Here we have angle S and angle Q. So one of the properties of a parallelogram is opposite angles are congruent. So the equation we would want to use is 4x minus 9 is equal to 3x plus 18. And now we need to use our algebra skills, subtract 3x. So x minus 9 is 18. Add 9 to both sides, and x is equal to 27. At this point, we need to plug in the value of x to find the missing angle. So to find angle Q, we're going to plug 27 in for x. So angle Q is 3 times 27 plus 18. And when you do that on your calculator, you get 99 degrees. So angle Q is 99. Angle S is also 99. Now remember, the fourth property we talked about is consecutive angles are supplementary. So angle P here in green plus angle S add up to 180. So angle P is 180 minus 99, which is 81 degrees. If you'd like to pause the screen and try problem number 5, please do so. In problem number 5, we want to use the fifth property we learned, that the diagonals bisect each other. So the yellow pieces are going to be equal, and the blue pieces that I'm highlighting are going to be equal. So we have to solve two equations. The first equation would be 3w is w plus 8. The second equation would be 4z minus 9 is equal to 2z. And now we need to do some algebra. For the problem on the left, we'll subtract w. 2w is equal to 8. Divide by 2. W is equal to 4. For z, I'm going to subtract 4z from both sides. So negative 9 is negative 2z. Divide by negative 2, and we will get z is 4.5. But we're not done here because the question is asking for JG and FH. So we need to plug these values in to find those segments. So in order to find segment JG, JG is W plus 8, which will be 4 plus 8, which is 12. If I were to plug Z, which is 4.5, I can find JH. So JH is 2 times 4.5, which is 9. If I were to find FJ and do 4 times 4.5 minus 9, I will also get 9. So then adding those two up to get segment FH, FH is going to be 9 plus 9, which is 18. I'm going to put a box around that answer. So the next four problems are practice problems to make sure you understand the properties of parallelograms. It would be my suggestion that you pause the screen and solve each of these problems on your own, and then play the video and make sure you did them correctly. So let's make sure you did problem number 1 correctly. Angle D and angle G are consecutive interior angles. So the first step is these two angles add up to 180. You then combine like terms to get step 2 here in yellow. So add 41 and you will get the step in green. Divide by 17 and you get x to be 13. The next step I did is I took 13 and I plugged it in and I found angle G. And when I plugged in step 4 here that I'm underlining, I get angle G is 63. So if angle G is 63, I also know angle E is 63 degrees because they are opposite angles. So the answer to this question is angle E is equal to 63 degrees. Go ahead and try problem number 2. In problem number 2, we learn a property that the opposite sides are congruent. So the first equation that I wrote in here in blue is 3x plus 6 is equal to x plus 12. We also know that 7x plus 10, highlighting in green, is equal to 2y plus 15. So those would be the two equations you will solve. When you solve that, you will get y to be 1 and x to be 3. Now be a little careful here. The question does ask, find the perimeter of PQRS. Perimeter is the distance around. So we need to plug in 3 in for x, and we're going to get 15. When you plug 3 in for PQ, you will get 15. Then you need to plug in y is 1. So 7 plus 10 is 17. When you plug in 1 on the other side, you get 17. So when you add up the sides, remember perimeter is the distance around. So the perimeter is 17 plus 15 plus 17 plus 15. So the perimeter is going to be 64 units. Let's take a look at the last two examples on page 8. For problem number 3 on page 8, we want to find angle P. So looking at angle S and angle Q, we should identify them to be opposite angles, and opposite angles in a parallelogram are congruent. So the equation we should set up is 2x plus 22 is 5x plus 4. When I solve this problem, subtract 2x. we get 22 is equal to 3x plus 4. Let's subtract 4 from both sides. 18 is equal to 3x, and divide by 3. And we get x to be equal to 6. At this point, we need to find angle P. So in order to find angle P that I just highlighted in blue, I'm going to take the value of x and plug it in for S. So 2 times 6 plus 22 is 34 degrees. Likewise, when I plug in 6 in for angle Q, I get 34 degrees. So I feel confident I did the problem correctly. So then to find angle P, since P and S are supplementary, is 180 degrees minus 34 degrees. And therefore, the measure of angle P, when you do the math on your calculator, is 146 degrees. So the answer for problem number 3 is 146 degrees. Let's take a look at the last problem, number 4. So number 4, AE is 4x plus 5. So that's this yellow segment. I'm going to label it 4x plus 5. And then CE is 15 minus x. We learned that the diagonals bisect each other, so these two pieces are equal. So the equation we want to solve is 4x plus 5 equals 15 minus x. I'm going to add x to both sides. 5x plus 5 is equal to 15. Take away 5 from both sides. 5x is equal to 10. Divide by 5. And we get x is equal to 2. At this point, I need to substitute in. So AE will be 4 times 2 plus 5, which is 13. EC is going to be 15 minus 2, which is 13. And that's a nice check because they are equal. The goal was to find AC. So AC is the whole diagonal, so 13 plus 13, which is equal to 26. So the final answer there is 26. So I'm hoping you found this video useful in terms of finding and utilizing the properties of a parallelogram.